Hi everyone, today I'm presenting my 4x4 matrix multiplication accelerator on the DE1 SoC board. Here are the controls. Key 0 representing the reset of the system. Key 1 will be start of the process. Switch 0 will be toggles between data Z0 and data set 1. Switch 1 and 2 will show the 7 segment display, either the checksum, cycle count, matrix cell, or current FSM state. For switch 3 until switch 6, we'll do the step calculation for our binary code. First, I select the data set 0 by keeping the switch 0 down. Right now, switch 2 and 1 will be up, and hex 5 shows 0, confirming the state machine is in idle. I will press the key 0 to reset, and press key 1 to run. As you can see here, the code finishes executing instantly. LED 0 turns on and hex 5 changes to 4, proving our FSM successfully stayed through the done state. And then I will switch the 2 and 1 both down, and display will show our checksum of this dataset, which is BC5C. And then I will switch 1 up. This will show the cycle count of our dataset 0, which is 14 in hexadecimal, which is matches our 64 cycle requirement. Now, keeping switch 2 up and switch 1 down, we can probe individual matrix cell using switch 5, 4, 6 and 3 as address. So I will start the board, and for our first cell, it will show 38 when all address is 0. When I toggle the switch 3 and switch 5, make it address 0101, it will show A3 as the result. Next, I will select the data set 1 by flipping switch 0 up. I will hit the key 0 button to reset and key 1 to run. And then once again, this is our checksum for data set 1. And then when I flip the switch 1 and switch 2 up, we'll see our FSM state, which is it will confirming our clean done state. And then I will turn the switch 2 down. This will confirm that our clock cycle still 40 in hexadecimal and in 64 in decimal. For data set 1, I will toggle the SW0 for data set 1, and then I will toggle the switch 2 to see the 1 cell matrix, and then I will start. And as we can see, for the first cell is 13E02. If I toggle the switch 3 and switch 5, I will get the value of 6A. That is our second cell.